Mic check, mic check. Testing 1, 2, 3. Testing 1, 2, 3. Testing. Testing 1, 2, 3. Testing, testing. 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 Testing 1, 2, 3. 1, 2, 3. 1, 2, 3. Testing 1, 2, 3. Testing. All right.
Yeah. Hey, thanks everybody for coming tonight. We are going to start our presentation, so you can just adjust your chairs and sort of focus them on the screen. Nice, nice. Yeah, so Mariah's not here today. She said she's violently ill, and I think she's helping with the live stream like right now. So yeah, tonight we're gonna have a presentation from Chris Brousseau. Wait, is that how you say your name? Okay, nice. Yeah, from Chris Brousseau. Chris studied linguistics at BYU like 4 years ago. And since then, he's been doing various NLP things. Right now, he's a lead data scientist at MasterCard. And yeah, like on social media, he strikes me as someone who's thoughtful and pretty connected with the space. So I think this is going to be a pretty exciting presentation. Yeah, so with that, do you want to take it away, Chris? Oh, also, there's an ask that we wear our masks during the presentation. So.
Thanks so much. All right. So I hope that most of you have seen this title before. It's probably why some of you signed up for this event, Multilingual Classification. I would love to get us started off with just like a short introduction on what classification is, because I know that there's some beginners tuning in, and then we'll jump right in. Basically, classification is where you throw inputs at a function, in this case a neural network, and you come out with one of several classes. There's binary classification, there's multi-class classification. We are going to focus mainly on the latter, multi-class classification, because there's not really a way to segregate language into nice little classes. So for those of you who are familiar with classification, why would you ever want to make it multilingual? Why would you want to classify text in the first place? There are tons and tons of applications, but I think these points over on the right are going to sum up the why make it multilingual part. The first one is by far the most controversial. Multilingual models actually outperform both monolingual and bilingual models now. That's cool. This 2021 was a groundbreaking year in NLP because of this reason. The second part is purely monetary. It's a very easy equation. More languages equal more customers. You know, if you are only touching the English speaking part of the world, you are missing out on most of the world, and therefore most of the world's money. It's not very difficult to understand that. The next part is a little stipulation. How do you tell whether your data set is already multilingual? If you have like an 80-20 split between two languages, it's not multilingual. This is more of a language agnostic situation, and I would advise you to go down that route. We're going to talk more later about how to recognize different data paradigms for this, but that's just like a ground rule in the beginning. You want it much closer to like a 70-30 split or 60-40, or I mean, best would be 50-50. If you can get a uniform distribution across all of your languages, That's a perfect data set, right? The next part, special tokenizers. So this is another reason why you would want to make something multilingual, and a way to make it easier is really customizing your tokenizers to make sure that your inputs are super clean for your model. What are the risks? Essentially, you're risking speed, although not a lot. Multilingual models do tend to end up a lot bigger than monolingual and bilingual models. So this is part of understanding your problem. You want to make sure that you know exactly what your task is before you enter that multilingual space. But if you've analyzed it well enough and you understand the risks, it's not a difficult decision to make. And then the last one, I've already mentioned this a little bit. Are you sure that this is a multilingual problem? You have multilingual problems, you have cross-lingual problems, and you have language agnostic problems. I would wager that most of the problems that that you will encounter in your machine learning or data lifespan are going to be either language agnostic or cross-lingual problems. And we'll go a little bit into those differences as we go through this. Okay, so here is a little bit of cherry-picked data from Facebook AI from FAIR, where they recorded last year beating their own bilingual agents in a translation competition for the first time ever. So that's pretty cool. The reason that this is groundbreaking is that the model that beat the bilingual one was trained pretty equally on about 104 different languages. And the whole contest was between two. It was just English to German translation. And the multilingual model that had 104 languages floating around in it won, as opposed to the one that was trained on just English and German. Does anyone have an idea of like why that would be? Just logically, just think about it for a second. Go ahead. Generalization. Explain that a little more. That the multilingual model would get a better general representation of language. Is that what you mean? Yeah, essentially anyone who speaks more than one language, a lot of people who are monolingual are aware that language doesn't exist in a vacuum. You know, you have Portuguese words that are inherited from Arabic. You have Russian words that are inherited from French. You have English words that are inherited from everywhere. You know, language is not stuck in one space and never comes in contact with anything else. So it makes sense that these multilingual models would be able to generalize better. That's a perfect answer. Okay, let's keep going. So here's a teensy bit of history about multilingual classification and some model names in case you're interested in implementing this yourself. And I apologize if you're advanced. I'm trying to get us all to the same spot so I can hopefully knock your socks off. But so this first one, MBERT, it's exactly what it looks like. It's multilingual BERT. It was trained on 104 languages, really similar to the model that Facebook beat their bilingual model with. That evolved into XLM, where you'll see these first three are encoder-based models. So XLM is exactly like BERT, except they added a new task and they had different training data. That new task was translation, where they would do mask language modeling along with translation to try and get it to generalize over languages as a whole. That ended up not working out too well. And Facebook or Google DeepMind actually came out later with XLM Roberta, which you would think would be at least related to XLM. It's actually not. It's just an extra large language model is what that stands for. It's Roberta, the exact same algorithm as BERT, but they got rid of that translation and just trained it over as uniform of a distribution of languages as they could. Just a really massive data set. The next one is probably one that you've heard of, T5, the text-to-text transfer transformer. This one is interesting because the whole point of this model was to kind of explore the limits of what a transformer could do. So they didn't actually change any of the original transformer inputs or layers. You know, they tweaked them a teensy bit, but this just kind of an update, you know, transformer 2.0. So it's exactly the same as BERT, except it kept its decoder. You know, it has both encoder and decoder layers. And the big thing with this text-to-text transformer was instead of having different formats for your different tasks, if you were going to do glue or super glue on this, which glue is the general language understanding evaluation, comparing the models to human baselines. If you were going to do that, instead of doing different formats for all of your data, you would just prepend, I want to do this task, colon, and then there's your sequence. That's pretty cool. And then MBART. This is, it's actually a little bit older than text-to-text transformer. However, it's become a little bit more relevant because of how well it works on the translation task. And specifically, even though it was trained on translation and translation only, it's shown to do very well within a supervised paradigm for sequence to sequence. So if you're hoping to get language out of your model, this is a cool place to turn, even though it's meant for like it was originally trained for translation. It does work very well and it learns very well. So do we have any questions about these? I'm sorry, I kind of threw this at you out of left field, but I wanted to give us all an introduction before we go ahead. Cool, I'm gonna move on. All right, so yeah, based on that research in 2021, FAIR and DeepMind and a whole bunch of researchers from everywhere from Cambridge to Thailand have found that these multilingual models going for multi-targets actually do outperform. But I want to be really super honest with you guys and show you those are actual numbers. You know, the lowest one is like 62.3 and the highest one is 72.5 for the pink bar, and the lowest one is the BERT monotarget for the darker bar, and that was like 81, and then the highest one was like 83. You know, you're not getting extreme performance boost at this time. So if you've how do I say that? If you have hard business requirements for speed and latency, it might be better for you to do that monolingual model instead of the multilingual one. The reason you would turn towards a multilingual one is for an international model. Stuff like what we're doing here at MasterCard. You know, we're dealing with Canada and Europe and Africa and Brazil and Australia. And that's like, there's a lot of different languages. There's a lot of different formats that we have to deal with. And so our use case is very multilingual. Okay, so here we're stepping into making the actual multilingual models better. This first technique was pioneered by Jeremy Howard and a research team. If you recognize that name, he's from FastAI. It's called ULMFIT, that stands for Universal Language Model Fine-Tuning. You can see up on the top, that explains the very first part of ULMFIT, which is where you train only the classifier first when you're doing this transfer learning. So this is why I introduced those models to you, is the best way to do multilingual modeling in the first place is transfer learning. You take a model that has already been trained on a multilingual data set and you fine tune it on a task that you care about. And this is one way to really jumpstart your performance on that task, is by freezing everything that the model has learned in your first iteration, except for only that final layer, which is the classification layer, and then letting it just learn the classifications with all of its previously learned embeddings and hyperparameters, right? It makes sense. You will gradually unfreeze during training so that you're only hitting those like initial inputs near the end when your learning rate is lowest. And that's this second graph. This is your triangular slanted learning rate, where you pop your learning rate up really high in the beginning when you're training the classifier, because you want those to change. And then you drop it down as you are unfreezing the layers so that you change less and less as you're going through. Because the models have already proved successful on recognizing language and doing things with it. And so you don't want to change that part of it. You just want to change what the classes are. Here's a little bit of a comparison for with and without ULMFIT, again, to hopefully give you another tool in your toolbox so that you can know whether or not it's a good situation to use it. If you do use ULMFIT, you'll immediately have good few-shot learning. So if you have a small data set or you're trying to do multilingual in a very underrepresented language, something like Slovak, you know, that doesn't, like, This strategy will help with that. The problem is you are going to need a lot more data in order to get it to generalize over everything, as opposed to just these few shot use cases that you would find. The second reason you wouldn't want to use it is it's prone to overfitting really quickly, because you have such a high learning rate with the classifier layer. Or shoot, I did that backwards. Without onFit, transformers are prone to overfitting really quickly because they're learning the full context. With onFit, with that triangular slanted learning rate, you're actually a lot more stable. And that's repeated in the third point, that this inductive transfer learning is a lot more stable because you aren't changing the whole model at once. The other good news is that with onFit, it's faster. You know, your training can be done a lot faster because you aren't activating all the layers and you don't have to backprop through all of them the whole time. It's faster, it takes less memory. Those are both good things. Go ahead. You can actually use any of them. However, this was done back when stochastic gradient descent was super in style. So yeah, you can use Atom, you can use whatever you want, but that's what was done here. And the reason I say that, the reason I talk about stochastic gradient descent as if it's not in style is it just is very difficult to make it work on a language scenario because of what are called exploding gradients. Language, go ahead. Oh, what? Oh, thank you. Yeah, the question was what optimizer is this used with? But so it's one of the main tenets of language, and this is one of the things you'll learn if you go to any linguistics 100 class anywhere, just the 101 level. There's 6 basic characteristics of language. One of those is productivity, meaning that I can say a sentence right here, right now, that has never been said before by any person in the history of the world, and all of you have a decent chance of understanding me using brand new words. You know, that can happen. And because of that, it's very difficult to take the derivative of whatever you are, of your slope. You know, you can't, it's very difficult to find a global minimum in a situation like that where you're building large language models. Okay, so this is the hardest one, and that's the reason why I put it second, so that I could trap you. I wanted to hook you first. You have to know your data. And there's no silver bullet for this. You have to know your task inside out. You have to know your data in order to really improve your model. Otherwise, you end up with something like is on that graph, where your system is really well explained, and then you just have magic fairy dust NLU just inserted in, right? That doesn't happen in real life. That's not something you can just do. There's some pretty cool things you can do out of the box, but I'll give you examples. I don't have a slide detailing the failings of larger companies in this space because I don't like doing that. But say you were to build an English model for generation, right, a language generation task. We have never seen infixes be naturally generated by a model ever. And we use them all the time. And I think that's unfreaking believable. Right? That's an infix right there. Unfreaking believable, where I just put it in. That happens all the time in conversation, and yet the model's never generalized to get that. And it's partially because we don't insert it into the data, we consider it to be wrong or something like that. And so our data actually isn't reflective of how people really talk. That causes problems in a lot of different ways, whether it's translation, always defaulting to one gender for certain tasks, or there are a bunch of different problems that come up just trying to sprinkle, the generalized NLU dust on whatever system you're trying to employ it in. And one of the fun things about that, I'll talk just a little bit more about it, is that native speakers a lot of the time are not even aware of these rules. You get, like if you have a Russian language model, that's something very dear to my heart. Most Russians never think about the prefix po as referring to a locative case. They always use it in the dative. It's always потому что, or something data после, but they never think of потом, even though that definitely is locative, and it definitely is something people say all the time. And I'm sorry if you don't understand Russian, but it's just trying to illustrate that we do things all the time that we don't keep track of in our brains, and I don't want you to do that with data. I need you to keep track of your data and keep track of your task and your models so that you can actually optimize them and make them pristine, because that's how you make the big bucks, right? Is competing against people who aren't paying attention. Okay, so some things to know about how to make your data multilingual, if that is your task. Number one, I put a U. I tried to get that cute little fancy U that stands for uniform distribution. I couldn't find a good white one, but yeah, that's uniform distribution is what you're going for. If you find your data set severely imbalanced, please correct it. You can either augment the one that's not represented, or you can just cut stuff out that you find is not as useful. But the point is you have to know both sides of it in order for either of your decisions to actually help your model. The second part, or I guess I'll talk about multilingual tasks versus cross-lingual tasks. Are you, I guess the easiest way to explain it is, do you know what language is coming in? If you know what language is coming in, you don't have to run any sort of detection at any time. You're doing a cross-lingual task. It's the best way to differentiate between them. Multilingual tasks, you don't know what language is going to go into your model, and so you have to be prepared for everything. Or you may know what languages are in your data set, but you don't know at one time whether it's going to be one or another. So second one, linguistic roadblocks. If you are interested in leveling up your NLP, there are a lot of people who have written some really great books. The one that I like to shout out is Emily Bender. She's up at the University of Washington, and she's spent like the last 10 years of her life writing books about linguistics for AI and linguistics for NLP. There are books on MIT's book list right now that are free and available to read about. And so you can become more familiar with these words like vocab density. There's a funny use case for that we just ran into a little while ago, where we were analyzing this huge data set, 10 million inputs, and they were all language based. And we realized that there were only 1,900 unique tokens in the entire data set. Like, it just kept reusing the same things in different orders. And it changed the whole way we were modeling the problem and the whole way we were thinking about it. But the fact that we knew to look for that was what kept us from making a big mistake and, providing a huge model that could handle anything to just handle 1,900 words out of 10 million inputs, right? One of the biggest mistakes that I see, especially in newer people to NLP, is not analyzing your stop words and not cleaning that list before you do any sort of pre-processing on your data set. Does anyone have a question? Do you guys know what stop words are? Cool. Stop words are lists of words that generally you should not include as part of your vocabulary in your model or your tokenizer. Those are the two big parts of NLP and language models, or your tokenizer and your model. Both of those have vocabulary that you essentially get to assign out to it. You don't have to. A lot of things like Hugging Face will do it for you. But the fact of the matter is, you don't want to fill that up too quickly with words like the or no. Even if we feel like they are semantically significant, the model will perform better generally on tasks like what I'm describing if you take out all of the most used and least understood words. Least understood, that's not a good way to explain it. Most used and least utilized words. I don't know if that's a good way either. I hope you get what I mean. But so that's a mistake that I see very often, is people just download the stop word list from NLTK. They don't even look at it, and they just throw it in their model. And then they're like, oh man, like I'm only getting 58% accuracy and my precision and recall are negative. Go ahead. Okay, so the question is, do tokenizers encode different languages differently, or is it a shared context? And the answer is, I have a whole section about this. So we are going to get to it. It's a great question. The last part about this is just understanding that at this time, there is no completely optimal approach other than you have to dig in. You have to dig in, you have to figure out what you're doing and why you're doing it. And that's the only way you can really optimize what's going on in your data. As far as the model and the tokenizer, we're going to get to, well, the model, you have stuff like OMFIT, the tokenizer we're going to get to. Okay, so here is the human element. Machine learning has been plagued for the last maybe 60 years with an appeal to nature. That like we are modeling neural networks off of the neurons in your brain, and we are going to do machine learning, and it's going to learn like a human. We are going to compare everything to human benchmarks. It's all like a human. So I wanted to ask you guys, how many of you actually know a language that is not your native language? How many of you are fluent in the second one? Okay, a lot of you, right? So here's a question out to the group again. What is it like for you as a human to know multiple languages? Do you just have words floating around in your head all the time from both languages and they come out willy-nilly from both languages? Or do you kind of switch between them? What do you think? I'm giving you a spoiler here. Code switching. We switch between them. We have a shared lexicon. We have a shared processor. We do not have a shared tokenizer for all of our languages. And that's a little bit controversial, but I am backed up by a lot of research here. So I'm willing to stand on that point. We as humans code switch. And so I'm going to appeal to nature, same as everyone else has before me, and say, we do this for a reason. And if our models do it, our performance will go up. And that second part is actually empirical, and you can test it. If you have a truly multilingual situation and you have a different tokenizer for every single language, it will go up. And you train all of those tokenizers with language-specific vocab on language-specific data. You don't let them mix a lot. The improvement goes up every time. And I hope that it's intuitive for you guys to understand why. That basic why is knowing that, if you put bad things into your model, bad things are going to come out of your model. And so if you get your model mixed up between a whole bunch of different languages that all use English characters or English similar characters, it might split words in a weird way, or it might think something is a token in a language where it's not. And even though there's a lot of stuff that will end up hopefully mitigating that within your model, you do, I have, and I'm pretty sure all of us have, whether or not we are aware of it when we've worked in this space, you do have those influencing end results and causing false negatives in places where you don't want them. But for this, code switching is where you switch between languages or dialects or personas even. People will code switch between American Standard English and African American Vernacular English pretty often, depending on what situation they're going to be in, or again, in worse terms, basically, poor people who learn how to talk like rich people end up talking like rich people when they're around rich people. It's kind of a sad reality of our existence, but it's important to acknowledge, and it's important to understand that this affects our machine learning as well as our daily lives. It's not always that dramatic. It's like I code switch when I talk with my family. I speak to my family much differently than I speak to you. I'm a lot more formal here. But so here are some applications of code switching in natural language understanding to help you kind of understand all of what this means. Basically, you want to solidify a lexical boundary in your pre-processing, but not your processing areas. You want different tokenizers for each language. You want an English-specific tokenizer, a French-specific tokenizer. You want all of FIGS, which FIGS is French, Italian, German, Spanish. Those are the most localized and translated languages. For all of you want a different tokenizer for each one. You can, if you are in one of those cross-lingual situations, or if you just want to play with fire, you can just do a byte level BPE tokenizer for the whole thing and say, hey, we're not even going to worry about letters or orthography. We're just going to put it all into Unicode and see what comes out. You know, the next part, different pre-processing functions for each language. You know, this goes back to the stop words I was mentioning. You want different stop words. I guess that's number 3, but you want different functions to clean the text. You know, if you're using NLTK punched, they put a lot of effort into making sure that you aren't taking out, you know, I kratka or like accent aigu, you know, all of the different accents and diacriticals that come up in different languages, but even they mess up on that sometimes. They can't get a perfect solution. It's not easier, it's a bit more work, but it's a lot more worth it to actually create those cleaning functions for pre-processing for each language individually if you're going to process all of them. Different stop word lists. You know, you don't want no being taken out of your check. That's actually a really important word in Czech. You know? But you do want it taken out of your English a lot of the time, unless you're doing like really strict sentiment analysis. 4 and 5, you'll notice optional tag on them. These go back to knowing your task and knowing your data. You can do different static vocabularies for each language if you want to partition your model that way and only call part of the model to process part of the data. That's really use case specific, and it's only going to happen if you use really big models, but you can do it, and it helps sometimes. Another one is different word embeddings for each language. So this goes back to the question of, do the tokenizers create different word embeddings based on language? They can, and sometimes you need to. Do we have any questions here? This is a lot of information I just threw at you. Go ahead. Oh, sure. So what is the definition of a tokenizer? Let's take a sentence. Let's say the sentence is, I love my mom, right? A basic tokenizer is just going to split it at the white space. It's going to have a token for I, token for love, token for my, token for mom, right? When you train a tokenizer and these tokenizers are what you use to get a sequence or a string into the proper input IDs for whatever model you're going to be using, because all models are going to need it to be numerical eventually. You know, it's got to be in a tensor. So this is how you convert that in a nice automated way. And you can train tokenizers. Generally, if you're using Hugging Face, or I think Keras as well does this, they'll train a tokenizer alongside the model on the same data. That tends to be very easy to do. And you can do some really cool stuff, like I said, out of the box with it. This is where you're leveling up. You're taking that next step and you're training the tokenizer by yourself on custom data. Does that make sense? Exactly. Yeah. This is where you have to step out of the trainer.train parenthetical and write your own trainer, because it's going to have to switch, you know. Okay. Any other questions? Go ahead. Oh yeah, yes. Okay, question was, do stop word lists already exist? Like predefined stop word lists exist for each language? Yes, they do. And you can find them very easily. Natural Language Toolkit is prolific for having these just on hand. What I'm saying is you need to open that up and read it and figure out whether or not you need all of those stop words, or maybe you need even more stop words than what they have. You know, that's where you get into the task specific stuff that is hard and no one wants to do it, but it really makes your model just shine, you know. Okay, here's my actual question slide. Feel free, if you don't want to speak up in a group setting, send it to me on LinkedIn. I'm happy to talk with you. Does anyone here actually have any questions about anything that I've said in here? Go ahead. Good question. Yeah, so that is a multilingual classification problem, but these problems, like you said, they are very broad. That's kind of why I picked this, so that you can find anywhere to apply this. Another application was something that we're working on right now is taking in language data and outputting different classes for transactions, bank data. People that use MasterCard, they get like description memos and stuff, and we'll classify them. That's a huge space right now. You have, this is going to be controversial too. Sentiment analysis is a good example of a multilingual classification problem. In fact, I have this. So if you go to my GitHub, I prepared this as like an activity if you want to. It's not part of the presentation, but I have this this XLM Roberta train and hyperparameter search Jupyter notebook at my GitHub that I purposefully wrote badly, but also good for you. So the activity here is to pick it apart and figure out what I did wrong. This is on the multilingual Amazon reviews data set. So you are going to get a text of a review, a real review that somebody wrote, and your job is to output a prediction of how many stars that review coincided with. And it's in a bunch of different languages. And the paper, like the original paper that I was looking at, got 51% accuracy on this. And I thought that was really good because it's not a binary classification, and that is pretty good. If you just run the model as is, the way I've written it out, you'll get 59%. However, I have another version of it, promise not to cheat, but there's another version that can get up to 78%. You're getting like a 20% boost in accuracy just by doing some of these things that I talked about here. And you can go even further. I mean, this was something that I did as like a side spare time thing. So if you want to really level up in this space, that's something that I would recommend. I'd also recommend, Emily Bender's books. They're Linguistics for AI and Linguistics for NLP. They're very good reads, and she does a very good job of explaining both the linguistic and the NLP concepts from the ground up in ways that you can replicate, which is very cool. Go ahead. Good question. What are NLP problems that most companies have a use case for? Number one is going to be some sort of optical character recognition. Most companies at some point or another deal with PDFs. In the localization industry, we like to call those pretty darn frustrating because it's very difficult to just extract text from them. And so that's number one problem that I see everywhere. Most companies that deal with NLP have some sort of a classification or a sentiment analysis. If you're in sales, that could be classifying, like, this lead is cold, this lead is hot. We should send this lead to the sales team to recontact. Their whole company is based on that. A lot of speech companies end up doing things like text to speech or speech to text or both. Something that I worked on at Lingotech, or not at Lingotech, at a previous company, was essentially a continuous generation system for language. We had a voice activated device that would speak to people, kind of like an Alexa assistant or a Siri assistant kind of thing. And we noticed that people kind of got stagnant as the same responses got stagnant. And so I created a model that would output semantically the same statement, but switched up a little bit. That first part was a paraphraser, and then that happened, and then we would gauge the user's response to it and either paraphrase or not paraphrase based on the sentiment analysis of their response. And it just kind of looped. It was really cool. There are tons of problems though. If your company deals with language at all, there's almost a guarantee that you're going to have some sort of a linguistic classification. I can't guarantee it's going to be multilingual, but there's going to be some sort of a text classifier going on. Good question. That's a good question. You have to detect it. Or a lot of the time in data sets, like if you do this Amazon reviews problem, a lot of the time you will have a tag associated with either the country or the language it was originally input. You can use that to kind of cheat for the model and get so that you don't have to do that linguistic detection. So you can automatically tee up the right tokenizer as it's going through that first portion, just the cleaning and pre-processing. But if you don't have that, you will need to run some sort of a detection. You can build that yourself. That's a multilingual classification problem, detecting what language something is, or you can use an API. There are a myriad of them, and most of them are free. Cool. No more questions? Well, go ahead. How prevalent are subword embeddings in multilingual space? Very. Super a lot. If you think about a prefix, all prefixes are subword and all prefixes get embedded as separate tokens because they show up multiple times, like redo, whatever, retrain. That is a subword token that is going to have embeddings attached to it as it goes through the tokenizer. Good question. Same with suffixes. I mentioned infixes, but we don't really do those yet. Maybe that will happen in the future. Go ahead. What kind of projects can I do to be taken seriously as a person who does NLP? I don't know. I don't know if anyone takes me seriously. The first project that I ever did that really caught people's attention was building my own search engine, which that's a language problem. Google would be nowhere if their search engine didn't understand the language that you put into it. It would be nowhere if you could only put English into it. That was a huge one, just because it took a lot of work and time and blood, sweat, and tears on my end that I wasn't getting paid for. I think some of the biggest ones that you can do for yourself right now are language as it pertains to video. Take a video of yourself and put it through your model and make it look and sound like you are speaking a language that you've never spoken before. That requires computer vision, that requires NLP, like a hard dose of NLP. But it's possible, and there are some GitHubs that already have it kind of out of the box. I would recommend that you try to do it from the ground up and just use those as a resource, because if you do go through it, you're going to go through probably every single problem that exists in the space at least once. And that's cool. Good question. Go ahead. Hire a linguist. That's a little plug. For anybody who actually is in a hiring situation, I don't generally recommend that you hire linguists to be on machine learning teams. I have dealt with a lot of linguists in my life. I've been a linguist, and you need a particular type of linguist that actually understands the machine learning side of things. Otherwise, you're never going to get your project off of the ground because there's so many problems to overcome. The alternative is the one that we primarily address here, which is don't hire people who only do machine learning and don't really have any background in linguistics to solve linguistic problems. You need at least a baseline to know what you're looking for to understand that your data is imbalanced or that your data is just plain wrong or offensive. You know, that's very important. You need somewhere in that happy medium of they're probably going to be better at one than the other, but you need somebody who is familiar with both sides in order to effectively solve these problems. Good question though. If you come to a problem or if you come to a language that you don't understand, you should hire a linguist to help you understand it or to just do the work. Excuse me? Oh, good question. M2M. That is the first truly many-to-many non-English centric language model. It was developed out of FAIR. I've been following that. I've been following all of the papers that are continuing the work of MBART, making sure that your pre-training and tokenization is optimized for a specific linguistic task. With MBART, it was translation, which that one is dear to my heart, and that's why I like following that one. But yeah, M2M is groundbreaking because most of our language models, even developed outside of the US, end up being English-centric for our data. And there's nothing particularly wrong about that, except that the M2M model outperforms most of them because it can go from any language to any other language with very little trouble. That's a good question. I've also been following Muse lately, which I don't remember what that one stands for, but if you just Google MUSE, all caps, it's out of Facebook. You can read up about it. It's very cool. Good question as well. Any others before I end? Thank you so much. This has been a pleasure.
Man, thanks, Chris. That was awesome. Yeah, so Mariah asked me to say that next month, March 22nd, Tuesday, there's going to be another speaker, Shane Hansen, and he's going to talk about optimizing TPUs in Google Cloud. So sounds pretty technical and intense. So yeah, the rest of the night is basically yours to hang out, socialize. Mariah said last time that usually there's more pizza than people will eat. So take a pizza home if there's any left. And yeah, thanks for coming. Oh, sorry, actually giving it to Garrett.
I just want to at least say there's a bunch of people here with MX stuff on. Feel free to talk to us about what we do with data classification. Shane in the back wearing a PlayStation hoodie and a green shirt. You can ask him why he's wearing a PlayStation hoodie if you want. You can also talk to him about other things. But you're welcome to stay, hang out as long as you'd like. Well, reasonably. There are some people I'm sure would put me up. Don't realize that there's like couches and beds in that next room and they'd probably sleep there. We are hiring data scientists, data analysts, and we're throwing up some positions in the next few weeks for data engineering. So if you'd like to know what we're doing with data engineering, go ahead and reach out to Shane. He'll give you a sneak peek. And we're hiring data ops people to come build our next version of our data pipeline. So thanks for coming out. We're MX, and we'll host any of your meetups. So if you have a meetup you want to host, if you would like to use these resources, just talk to me and we'll make it happen. Or more Mariah. Mariah knows how to get in touch. Thanks, everyone. The question was, which seniority levels are we hiring for? Probably mid to senior at the moment, but honestly, a lot of people are really smart, and don't let that deter you. If you're interested, go ahead and apply. Sweet. Thanks, Chris. Thanks, Eric. Thanks, Mariah.